Is it going? Can't even tell. Yes, we are live. Okay, so first, let me just write out some stuff for you. So let's start out with the following. 17.36 milliliters of 0.250 lead to nitrate reacts with 47.61 milliliters of 0.175 molar sodium sulfate. Do you guys have your solubility rules on the blue sheet? Do you have your yellow sheet? You're probably going to want those. So I have a couple questions for you. Number one is how many grams of precipitate are formed? You already know how to do that. That's review from yesterday. Number two is going to be the new part. What is do you guys know what this symbol means? Brackets? Concentration. That usually means molarity or concentration. So what is the concentration of all remaining ions? So I'm going to give you guys a 4-minute head start to do part one. Part one is what we did 2 days ago. So part one, figure out how many grams of precipitate are formed. So do that first. So that's going to be write the equation, balance it, figure out what's the precipitate, limiting reactant, all that stuff. So I've been on, while you guys are working, I've been on a pillow journey to try and find a new pillow. I still have not found the one. I've been trying one for like the last 3 weeks. I decided last night it wasn't the one. Went back to my other one, got a better night's sleep. So I'm gonna have to return it. Most of these pillows have like a 60 or 90 day trial period. Yeah. I'll let you know if I find the one. Do you guys have a favorite pillow? No. Cam, you do? What is it?
I don't know what the brand is, but it's like memory foam, and it's like really like, not hard, but like firm. Because I don't like squishy pillows.
Is it thin or thick?
It's thick, on the thicker side.
Like, does your head sink down into it when you lay down?
Yeah, a little bit.
Okay. All right. You might need to look up the brand and let me know. I'm gonna start my work. You guys keep going. Lead 2 nitrate, maybe. Ay, 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 ay. Plus sodium sulfate. Plus two. Okay. Point 0. 6. What's up?
Ignore us.
Oh, okay, got it. It's fine. How are you guys looking so far? Are we matching so far? Yes. Did you guys get moles of PBNO32? Yes? What'd you get?
0.00434.
Do we have agreements on that? Yes. 0.00434. Later. Thanks for stopping. Yep. Moles of PBNO3. 2. What'd you get for Na2SO4? 0.008333 what? 2? Do we agree on that? It doesn't really matter what that last digit is. Moles of Na2SO4. Okay. For every one of these, I need one of these. That's a beautiful thing when you're figuring out the limiting reactant, right? So all we have to do is see which one is what. Which one's less, right? Yes? So which one's less? This one. So that means this one is my limiting reactant. Are we okay with that? Okay. So now I have to run this to grams of what?
Grams of lead sulfate.
Yep. So do that last step. Do you feel like my handwriting is better than normal today? Like, I feel like I'm really being intentional about my handwriting today. Rowan is agreeing, so okay. Also helps that I feel like we're not in a hurry today. When it gets towards the end of the period, we're like rushing and What'd you get?
I got 2.533.
That's not what I got.
I got 1.3162.
I got 1.32.
Oh, there's one.
Anybody else? What? Yes. 1.32 grams of PbSO4. Notice how I'm squaring important steps in my work? That'd be really helpful if you guys did that, like on a test in the future. Which, I have Rowan's test, so I'm going to be able to get your test back to you probably tomorrow. So, there we go. All right, step 1. Check. Step 2 says, what is the concentration of all remaining ions? Any ideas on how to start that step? What do you think you're going to do? Look back to yesterday's or 2 days ago. What do you think your first step is going to be? This is a direct continuation of yesterday's notes. Huh? We're going to have to split it into the ions, right? Therefore, we're going to have to write a net ionic equation. You got it. So I'm going to rewrite the equation down here. So here we go. I'm going to write the balanced equation here. So we have PbNO3 2 AQ plus Na2SO4 AQ yields 2NaNO3 AQ plus PbSO4. Wow, I'm so sorry. Okay. Step 2 is split that into the ions. So what are my ions going to be here? Pb what? Anybody? Yes. Plus what?
Plus NO3.
Be careful. How many NO3s? Plus 2 NO3 minus, because there's 2 of them. This is the first one where we've had any subscript that's not a 1. Plus what?
2 NA.
Plus 2 Na plus SO4 2 minus. You with me so far? Gives me 2 Na plus 2 NO3 minus, because we know that 2 distributes to everything, yes, plus PbSO4. I need to now find what are my what? Spectators. So my spectators are 2Na and 2Na and 2NO3 and 2NO3. Will those be remaining ions? Yes or no?
No.
Yes, because they're spectators. They're not doing anything. Okay? They're not part of the net ionic equation. And we're not even going to finish out the net ionic equation. It's not important. Okay? Because all I need to do is really just figure out our spectators. So I know I'm going to figure out the concentration of NO3. I'm going to figure out the concentration of Na. Do I need to figure out the concentration of, are either one of these going to also be left over? Pb or SO4? Yes. Which one and why? I'll give you a hint. Here's your hint.
Wait, no, that's a 4.
There's going to be SO4 left. Why? It's excess. That means that Pb2 plus is my true limiting reactant. So the Pb plus 2 ion is the limiting ion of this reaction, which is kind of cool. So it also means we're going to use all that up, right? Yes? So there's going to be excess of SO4 remaining. So that means I have to figure out the concentration of this, this, and this. So I'm calculating 3 concentrations. Are you guys with me so far? Okay. So we know that concentration, molarity, is equal to number of moles per liter. Agreed? So let's start out with NO3. So let's do NO3. So molarity of NO3 minus equals, how many moles of NO3 do I have? I have 0.00434. Do you see how we're putting those into moles?
Yeah.
How much easier that is? Times what? Times 2, right? You guys okay why that's 2? Because this is the moles of the compound, but I've got 2. Yes? Times 2 divided by what liters? Nope. Other guesses? Thoughts?
0.25.
Why'd you say that?
Because that's the molarity of the compound that it's in.
Let's go back up to the top.
Right.
Yes? What? 17.36 reacts with 47.61. If they're reacting, what did I have to do to them? Put them together, right? So what am I going to have to do to these 2 volumes? Add them, because you have to get the total volume of the mixture together. Agreed? Yes? So this plus this
0.0649.
is going to go way down here. What'd you say it was?
0.06497.
0.06497 liters. And the nice thing is it's going to be that liters for all of them. So you only have to do that one time. Does that make sense why we added those together? We poured them together in a solution, right? So the total volume is that. So molarity, NO3, is what? Tell me what you get. Anybody? Tim? 0.134 molar NO3 minus. We're going to do the exact same thing for Na. So let's go to, we've already written the equation. So do I really need to write that again? No. So let's go straight to MNA. So molarity of Na plus is equal to, I have how many moles of Na? 0.008332 times what?
2.
Times 2. So 0.008332 moles times 2 divided by the same liters, 0.06497 liters. Molarity Na plus equals That's not what I got. I got just 0.256. Check your work. Because if I have 0.008, 0.06. Okay. 0.2, 0.56 molar Na plus. So I have 2 out of 3 done. I've got the 2 easy ones done. For the last one, this is excess, right? So in order to figure out excess, I'm going to have to figure out how much I actually used, just like a regular excess problem, then subtract, right? So once again, I'm going to start out with my limiting reactant. So we have one more line of Stoich to do. Do you see how, like, if you make a mistake up in here, that could really be bad? Yeah. So, but you guys won't do that. So 0.00434 moles of PbNO32. I have to run that 2 moles of the excess, which is Na2SO4, right? So Stoich step, 1 mole of PbNO32 is to 1 mole of Na2SO4. Well, that's nice, right? So that means I used 0.00434 moles of Na2SO4 that were used. Are you okay with that? How much did I start with? It's right here. Yes. So I'm going to make a note down here so you guys know where all these numbers are coming from. So I started with this much up here. So 0.00832 moles minus what I used, 0.00434 moles used. That will give me my excess. Subtract that, what do you get? 0.00399 moles of Na2SO4 excess. Divided by let's not take the shortcut. So that means I have how many moles of SO4? The same amount, right? Do you see why I was going to just divide it? But I'll do it as the last step anyways. So that means I have 0.00399 moles of SO4 2 minus divided by the total, which is still 0.06497 liters. And that will give you your molarity of SO4 2 minus. Tell me if you match what I got. I got 0.0614 molar SO4 2 minus. Did you guys get something similar?
Yeah.
That is 80% of the notes for this chapter. We have one more thing we have to do, which is the last 2 questions on the homework, 89 and 90. But up until now, you should be able to do every other problem on the homework. Just let you know. Okay.